So, as you all know that presently we are studying what type of reactions, guys? Second type of reactions. That is what we used to call as. What is the second type of reactions?
Decomposition.
Decomposition reaction. So now, decomposition reaction we are having three types. So in last class already we have been completed the first type of reactions. That is what we used to say what? Thermal decomposition reaction. Clear? So now thermal decomposition reaction means with the help of what? With the help of heat. If you are making any carried out the any equation, any reaction, that is what we used to call it as thermal decomposition reaction. So first of all, what do you mean by decomposition reaction? Anybody? Please. Anybody? What do you mean by thermal decomposition reaction?
Like getting two or more products from the single reactant.
Yeah, so that is what. So a single compound is going to break down into two or more products. That is what we used to call as decomposition reaction. So this breakdown is happening maybe because of heat. If it is heat, we can say thermal decomposition. Maybe because of electricity. So if it is electricity, we can say electrolysis. Maybe because of light. If it is light, we can say photolysis. Is it yes or no, guys? So these are the things we have been studied. So in last class, I already explained you so many examples of thermal decomposition reaction. So anybody is having any doubt in that? Please let me know. So thermal decomposition, already I have given you so many examples, including how it will come, what is the formula, etc., etc. Now let me see. Somebody of you tell me what is the decomposition of lead nitrate? Lead nitrate. Anybody? What is the decomposition of lead nitrate?
Lead oxide plus nitrogen dioxide plus oxygen.
Very good. PbNO3 twice. Yeah, what is the state of this? What is the state of this? Solid state.
Solid.
What is the color?
Colorless.
Colorless. So colorless. Will start decomposing, heating. So we used to get a products called as, what is the products? Lead oxide. Understand what is the color of this?
Yellow color.
Yes, very good place. 4NO2, which is gas. What is the nitrogen dioxide gas? What is the color?
Reddish brown.
Reddish brown fumes. It is reddish brown fumes. You have to say plus oxygen gas. So this is one of the major example of decomposition reaction. As I told you, majority of decomposition reactions are what it is. Majority of decomposition reactions are what?
Endothermic reaction.
Yes, majority of decomposition. Very good. So majority of decomposition reactions are endothermic reactions. Why it is endothermic reaction? Because heat is required. Understanding, our energy is required to carry out the reaction. So that is why they are all called as endothermic reaction. So we can say majority of decomposition reactions are endothermic reactions. Understand? So still so many is not joined. Anybody is missing, please kindly tell them to join. So now, if it comes to today's class, today's class we are going to study the second type of decomposition reactions. That is what it is. You already know. That is only what is that, guys?
Electrolytic.
Yeah, decomposition reaction. So or else we used to say simply we can say what? Electrolysis. Clear, everybody? So now, even the heading itself we can understand electrolytic decomposition reaction, or we can say electrolysis, means a chemical reaction. Which chemical reaction, guys? It is decomposition reaction. Do you understand? So decomposition reaction carried out by what? Which will carried out by passing electricity. Do you understand it? So carrying out by electricity, that is what? Electric current. Then we used to call it as electrolytic reaction. So here also same thing. AB is going to split into what? A plus B. But instead of heat, we will write what, guys? We will write electric current. Do you understand, everybody? Or electricity. Then this is called as electrolytic decomposition, or we can say electrolysis. Any doubt? Please respond. So that is what. So by passing current or electric current, if we start decomposing any kind of compound, then we can say it is electrolysis reaction. Clear? So the best example is when current is passed through the water. Do you understand what? What is the formula of water? Please respond. What is the formula of water? Yeah, water, H2O. So if you pass the electric current or electricity, we can say. So it will what reaction will take place, guys? Decomposition will take place. So that what is the products will come? H2 plus O2 will come. So we have to keep here 2. So it is 2H2 plus O2 will come. Is it yes or no? So when current is passed through the water in the presence of a small amount of electrolyte, I will say you what is mean by electrolyte. All of you should understand that phenomena is very, very important. Maximum question will come. So in the small amount of electrolyte, then water breaks into 2 kind of products. What is the products, guys? Hydrogen and as well as what? Oxygen. Do you understand? Yes, please respond. Everybody. Yeah. Now if we take, as we take a pure water is a good conductor, bad conductor of electricity. Please respond. Pure water is a good conductor, bad conductor of electricity. Yes. Bad conductor. Very good, Mukesh. So that is what. So pure conductor is a bad conductor of electricity, or we can say which cannot conduct. Pure water cannot conduct electricity. You understand, everybody? Cannot conduct. What is that? Electricity. So that is why a small amount of pure water, we will add a small amount of acid. What will add, guys? Small amount of acid, so that it will turns into acidulated water. What we used to call, guys? Please respond. Acidulated. Understand? So yeah, spelling is mistake. So acidulated water, we can say. So this acidulated water only we used to call it as electrolyte. You understand, everybody? Acidulated water. So once if you add a little amount of acid, it will turn into what? It will turn into a good conductor of electricity. Do you understand, everybody? So if you take a pure water, it is a bad conductor of electricity. So that is why always we'll add a little amount of water. Then it will called as what? What we used to call, Pradosh? It is called as acidulated water. So actually this acid only we used to call as electrolyte. What we used to call? Electrolyte. So once acid is added to the water, this full water we used to call as acidulated water. So wherever the solution, what is the state of this? Anybody can tell me what is the state of this? This will be in liquid state. Yes or no? Please respond. So this liquid substance only where the electricity is passing is called as electrolyte. It's called as what, guys? Please respond. It is called as electrolysis. Now, let us understand electrolysis of water very clearly. Then later, different examples we will study. So now, if you want to understand the electrolysis of water, we need a certain kind of setup. So that electrolysis of water, you please keep adding first example. So what do you mean by electrolysis? First of all, what you written example definition? So AB is going to the decomposition reaction, which is carried out by what? Which is carried out by electric current. Is called as electrolytic reaction. So please write all of your definition. The decomposition reactions The decomposition reactions, still few are absent, please make them join. The decomposition reactions which are carried out by Sai, have understand Sai, Shahrukh? The decomposition reactions, please try to communicate with me. Always, then only you'll involve. You will involve and you'll improve. The decomposition reactions which are carried out by electric current are called electrolytic reactions. Adarshan, have you understand? Alada, Durga, that is. So you can write this is AB will give you A plus B, but what we are passing, Elmukel? We are passing electric current.
Electric current.
That is you have to remember. Okay? Yes, please. Clear? Any doubt? Now, example 1. Laksha, where is Ishal? Ishal is there. Tamil Ceylon is missing. Just check it, somebody.
Yes, sir.
Yeah. Electric current. First example. Electrolysis of water. What was to call, guys? Electrolysis of water. So, this is not a new process for you people. It is already class 7th or 8th. Already you have studied, but you might be forgot, most of you. So that is not a problem. Now, I will show you one diagram for you people. So the diagram is the phenomena where electrolysis process will be carried out. So that is electrolysis process of water, we can say. So, but other so many things we can do, so many chemical reactions which will carried out, which we can get individual substances by passing current. Okay. So now you all know water. Is it yes or no? What is the water formula, guys? Anybody? What is the water formula? Yes, please respond. What is the water formula? H2O. So now H2O means class 9th, I only taught you chemistry. Do you remember how to calculate percentage? Now H2O, you tell me how many moles of hydrogen and how many moles of water is there? I will explain you, Durga, again. Listen carefully. How many moles of water and how many moles of hydrogen and how many moles of oxygen is present? Anybody? If you take H2O, how many hydrogen molecules are there and how many oxygen molecules are there?
2, 1.
So 2 hydrogen, 1 oxygen.
The ratio, you might be studied the 3rd chapter, mole concept chapter. So this ratio of the individual substances is, here hydrogen is 2 and oxygen is 1. So the volume ratios will be like this. Have you noticed it, guys? Oxygen 1% and hydrogen 2%. Yes or no? Yes, please respond.
Yes, sir.
So now, this is the setup which we used to call as electrolysis. What we used to call? Electrolysis. Now, we are going to study what? Electrolysis of water. Very, very important one. So all of you remember, first the basic thing I will say you. So later you can understand. So this is what we used to call as stand. Okay, so now if you notice it here, we are having this container. Have you seen the container, guys? Everybody, this container, have you seen? Please respond. This full setup, including this one and including this one, everything, this all the complete setup, understand, we used to call it as electrolysis process. Do you understand? Now, if you take here, only we are taking here, you might be see the liquid present. Can you able to see the liquid here? Please respond, everybody. Can you able to see the liquid here?
Yes, sir.
Yes, please.
Yes, sir.
Yes, that is what we used to call as electrolyte. What we used to call?
Electrolyte.
Electrolyte.
In this experiment, what we are using electrolyte, water we are using as a electrolyte, but water is a poor conductor of electricity. So that is why I am adding something. What is adding? I am here. You can see here. What is
Sulfuric acid.
sulfuric. Understanding? Sulfuric acid means not more amount. Understanding? Little amount of sulfuric acid. For example, 90% you have to fill with water and little amount of sulfuric acid you have to add. So then this substance is called as what? Once if you add the acid, this is called as acidulated water. What is to call, guys? Acidulated water. Which will works like a good conductor. good conductor. Do you understand, everybody? Any doubt you can ask me. Now, have you noticed it? So this is the setup I have been taken. Now, can you able to see the black rods here? 2 rods is present. Yes, please respond. Everybody?
Sir.
Yes. So this black rods, both we used to called as electrodes. What we used to call?
Electrodes.
All of you should remember electrodes. So this electrodes is, what is the use of this electrode? Basically, they will be made up of graphite or carbon, we can say. They are made up of what, guys? Graphite or carbon rods. So this graphite rods, as we studied, graphite is the only good conductor. Yes or no, guys? Non-metals and good conductor. Is it yes or no? Please respond. Only good conductor. So that is why we will use this graphite in electrodes, manufacturing electrodes. Which is electrodes? This solid one. Can you able to see the black one here? Please respond. This solid one is called as electrode. So now let me observe the picture and tell me, somebody of you, what is the use of this electrode, guys? Anybody? What is the
Passing electricity in water.
Conducting electricity.
So electrodes will bring the electricity and take the electricity. Have you noticed it? Electricity is coming like this and it is going like this. Have you understand, everybody? So electrodes will be take the current to the water and take out the current from the water. So that is what we used to call it as importance of electrodes. So electrodes are the solid substances which will bring the current to the electrolyte and take the current from the electrolyte. Clear, everybody? Please respond. Yes, Ruti, Manya, Samaya, everyone. Now, remember, there is no positive, no negative electrode. Do you understand, Maitreyan? No positive, no negative electrode. Understand? Only we used to call it as electrodes. But if I connect positive node of battery, then that is called as positive electrode. What we used to call it, guys? Positive electrode. Understand? If I connect negative node, then that is called as negative electrode. So negative electrode, which we used to call as cathode, and positive electrode, which we used to call as anode. Can you understand, everybody? So cathode we used to call as negative, and anode we used to call as positive. Do you understand, everyone? Please respond. Any doubt? Yes, everyone. Now, you tell me, as we know that water will be going to split into hydrogen plus oxygen. So now you tell me, who is positive ion, who is negative ion, which is positive, which is negative? Which is positive, which is negative?
Oxygen is negative, sir.
Hydrogen is positive ions. Understand?
Okay.
And oxygen is negative ions.
Negative ion.
-2. So, Ishali, what happened, Ishali? Any doubt? So now if you'll notice it, remember, guys, 4 words I'm going to use now. One is cathode, which I already told you. Another one is anode. So now you tell me, cathode is positive or negative? You have to speak, I should not. You have to-
Negative.
Negative.
Everybody
Negative.
cathode is negative and anode is what?
Negative, sir.
Positive.
Positive.
Yeah, here I mentioned.
Cathode negative.
Cathode is negative. Clear? No confusion. Cathode is negative. All of you should remember. Anode is positive.
Positive.
Now, I am saying positive ions we used to call it something in our chemistry. What is that, guys? Positive ions we used to call it as,
Anion.
sorry, cation.
Cation.
Negative ions we used to call it as anion. Do you understand? So now you tell me. So as we know, always in magnetism also, always like poles will show attraction or repulsion. They will show
Repulsion.
Repulsion.
The same way, positive charge and positive charge will show remulsion. Negative charge and negative charge will show repulsion. So that is why, let me see somebody of you speak. Somebody of you speak. Cations will go towards to whom, guys? Cations will go towards
Cations will go to cathode.
Cathode.
go towards to whom?
Cathode.
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 Because cathode is what? Cathode is negative charge.
Negative charge.
Anions will go home. Anions will go towards the
Anode.
Anode is what?
Positive.
So once you set up this and you make inverted tubes. Why we are making inverted tubes here? Anybody? What is the use of inverted tubes? Manya, Samya, everyone. Because we have to collect what? We have to collect the gases.
Sir,
No.
we want to collect the
Yeah.
oxygen.
We want to collect the gases. This is hydrogen gas. And here what will come? Oxygen gas. Do you understand, everybody? So we have to collect hydrogen oxygen gas. That is why we are placing inverted tubes. You have to learn this process. Very, very important process. Electrolysis of water. This diagram also you have to learn. Do you understand, everybody? So here we are taking 6-volt battery and we are connecting this side positive node and this side negative node. So it will turns to positive cathode, positive electrode. That is what anode we can say. And this is negative electrode called as cathode. Now, cathode is this side. So who will come here, guys? Hydrogen or oxygen will come in this electrode. In this electrode, who will come? Hydrogen or oxygen?
Hydrogen.
Because
Hydrogen.
negative. It is negative. So who will come here? Here
Hydrogen.
ions will come. Do you understand? That is why cations will come. So is it correct or not, my statement? So have you noticed it? Cations is coming. But how many volumes? Hydrogen. How much volume? Two. Understand? 2 volumes of hydrogen. And how many volumes of oxygen? 1 volume of oxygen. Clear?
One volume.
But here if you notice it, sir, here space is more or less, but here space is more height. So then how you can say 2 volumes? Have you noticed it? If hydrogen gas is coming up, water will go down. Have you noticed it, guys? Yes or no? Initial,
Yes, sir.
this test tubes fully filled with the water only. Once gas is coming up, automatically water will be pushed away from the test tube. Do you understand, everyone? Yes or no? Please respond. So this total height, if you notice it, it is 2% ratio. And this ratio oxygen, how much percentage? 1%. Do you understand? So this empty space indicating what? Elmukal, what is this in empty space? It is filled with what?
Hydrogen.
Hydrogen.
And the empty space here it is filled with what? Oxygen. You
Oxygen.
understand? Notice this volume. It is hydrogen volume is more than double than the oxygen volume. Yes or no, guys? Yes or no?
Yes, sir.
Because in water, so the ratio of hydrogen is 2 volumes and oxygen is how many volumes? 1
One
volume.
volume.
If 2 volumes of hydrogen is collected, 1 volume of oxygen is collected. Sir, then industries, how, sir, we will do? So here they will keep opening. Where means I will show you. You just see. Here they will keep the opening and they will keep continuously collect the gases. Where means here. So here they will keep the opening and they will collect it to the tank. Understand, everybody? Here they will keep the opening and they will collect it to the tanks so that continuously hydrogen gas will store and here oxygen gas will store. Do you understand, everybody? Please respond. Now, you might be noticing oxygen cylinders. We are purchasing oxygen cylinders. Yes or no? Yes, please. Oxygen cylinders we are purchasing. Do you remember mountain climbers or else if it is those who are going for water diving and all, they will wear the cylinder backside. Have you heard? Please let me know. You know?
Sir.
Yes, sir.
Yeah, it is filled with oxygen gas because there is no sufficient oxygen which will be prepared. In industries, oxygen gas is prepared with the help of electrolysis of water only. Do you understand, everyone? Electrolysis of water only. The oxygen gas is prepared. Is it okay, guys? Please at least respond.
Sir.
Okay, so that is what you have to remember. So this is called as electrolysis of water. So if you pass the current, here 4 words you have to remember. What is the 4 words, guys? Cathode, anode, cations, and clear. So that is our textbook. That picture everybody should learn. So that picture is very, very simple. So this is one container and here one rubber car which will we have to fix the what? We have to fix the electrodes. Understand? And we have to make inverted tubes, 2 inverted tubes, and we have to take the liquid. What is that liquid, guys? What is the liquid we used to call it as? The substance which we are going to split.
Electrolyte.
Called as electrolyte, which we are going to split. Yes or no? Which we are going to break down. So, and this next one, this rods we used to call it as what? Electrodes. Understanding? So, if electrodes which are connected to positive and negative. Now, for example, this is positive, this is negative. Then this is called as what, guys? Anybody? This is called positive and this is negative. What?
Positive electrodes.
This is called anode.
Anode.
Cathode. So here who will come? Cations or anions? Anions will come. So which is negative. And here who will come? Positive. Understanding. Cations will come because cathode is negative charge. Anode is positive charge. Clear everyone? Any doubt? Laksha? Vishali? So this is what we used to call as electrolysis reaction. So electrolysis of water. This diagram is very, 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 very important. So always, what is the ratio? Hydrogen and oxygen ratio, guys, by volume. By volume ratio of hydrogen and oxygen. What is the ratio?
2:1.
2:1.
Hydrogen and oxygen equals to 2:1 ratio. Any doubt? Clear? Yes, please. That is. So this is what the first example. So you can write equation 2H2O, which will give you, this is electric current. What do we have to do? Electric current, if it will pass, we used to get what? Please respond. H2 plus O2 gas. That's all. So this is the first example of electrolysis reaction. All of you write it. Clear, guys? Any doubt? Please respond.
No, sir.
No, sir.
As I told you, when any kind of substance is dissolved in water, what is the state that is called as? Anybody?
Twice.
The aqueous state.
Clear? So that is what. So now all of you should remember, same way in electrolysis process, if it is in liquid state, any substance is liquid state, that is what we used to call as molten state. What we used to call, guys? Molten state. Understand? Molten state means in the form of aqueous state only. Is it okay, everybody? Clear? Please respond. That is what. So now we are going to get next the second example of electrolysis process. Not melted, molten state. Molten. Is it okay, Bahadrani? That is the meaning of that one. Okay. Now let me take molten sodium chloride. Anybody can tell me molten sodium chloride? What is the formula? Sodium chloride. Molten sodium.
NaCl.
Yes, which we used to call as, we can see, I am not mentioning here aqueous state. What I am mentioning? I am mentioning as liquid state only. You understand, everyone? That is you have to remember. So that is called as molten state. Understand, Elmokil, difference between aqueous state and molten state? Aqueous state means dissolved in water. You understand? Dissolved in water. And molten state means only the solid substance is directly converting into liquid state. That is called as molten state. So, molten state of sodium chloride. Sodium chloride, what is the formula? Anybody? NaCl.
NaCl.
It will pass electric current. What will come, guys? Anybody? Respond. What will come?
Sodium plus
Sodium will come, which is in solid state. Next, chlorine will come, which is gaseous state. Yes or no, guys? Please respond. So sodium metal will come as well as chlorine. Chlorine, what will come? Chlorine gas. Now, you tell me in this, which is cation, which is anion? Anybody? Pradosh? Monesh?
sodium cation,
Sodium
chlorine anion.
Sodium ions. Ions are whom? Anions are chlorine ions. You understand? So cations will go towards to whom? Cathode. Understand, which is negative, and anions will go towards to the anode, which is what? Positive. Yeah. This is the second example of electrolysis of water. Please all of you write. Second example of electrolysis of water. Any doubt? Please. Anyone having any doubt? You can kindly ask me. Clear, guys? Others?
Sir.
See, I cannot call everybody's name. You have to speak. If you have doubt, you have to get clear.
Yes.
So, in our textbook, page number 9, electrolysis process is there. The electrolysis process, the water, they are splitting into hydrogen gas and oxygen gas. But there, the connection they have been taken reverse. Positive, opposite side, anode, and cathode, they have been taken reverse. Means here, how I took here. Have you remembered? Like this electrolysis process, they have been taken. But the picture which I have been taken, they have taken positive this side and negative this side. Is it yes or no, guys? Yes. So whatever it is doesn't matter. So what we have to remember, negative is cathode, positive is called as what? Anode. Understand? If I take this side positive, here oxygen will come, here hydrogen will come. If I take this side positive, here who will come? Here now oxygen will come, and here who will come? Hydrogen will come. That's it. No difference. Yes or no, guys? Yes, please respond.
Yes, sir.
That is. So this is the second example of electrolysis of water. What is the second example of electrolysis of water? Please. What is that? Molten state. Molten state means, remember, a solid metal, solid substance is melted or converting directly into liquid state. That is called as molten state. Is it okay, guys? So whenever you will get molten state, what is the state of that you have to represent? Molten means what? Liquid state. That is you have to remember. Clear, guys? Any doubt?
Yes.
Yes. So for this, you please keep heading. What is heading you'll keep? Electrolysis of molten NaCl. What is that? Electrolysis of molten NaCl. Molten NaCl is this one. Any doubt? Now, next one. Keep heading. Electrolysis of aqueous NaCl solution. What is that? Electrolysis of aqueous. Aqueous means it is dissolved in whom, guys? Aqueous NaCl solution.
Water.
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 So this electrolysis of NaCl, but two. One is molten state, and is aqueous state. That is what I'm saying. Both in the form of liquid state only. So be very careful. Molten state means converting into liquid state, but your class 10, this is only the reaction which is very important for, but NTSC, we need this also. So electrolysis of aqueous NaCl solution. So aqueous means what will take, guys? NaCl, which is in solid state, which is dissolved in whom, guys? Which is dissolved in whom? Which is dissolved in? Do you understand? So, which will give you electric current, which will pass the electric current. Then we used to get sodium hydroxide. What we used to get? Sodium hydroxide. Understand, guys?
Hydroxide.
Plus hydrogen gas. Hydrogen gas. Plus we used to get what? Chlorine gas. Clear, everyone? Yes? Try to communicate. Then only you'll understand. Okay? So three products will come now. You might be, by this time, some doubt is running in your mind. What is that doubt? Anybody? Try to ask me. Sir, cathode.
Decomposition means first one element.
Yeah, that is what. See, hydrogen is positive ions, chlorine is negative ions. So hydrogen will come at H plus. It is come at cathode. Understand? And chlorine is minus, which will come at anode. This is what you are know. But where the NaOH will come? That is your doubt. Is it yes, guys? Yes, please respond. Aqueous state, correct? So now let us take the electrolysis process. Now, if we take the electrolysis process,